This is a project that was funded by VMD to try to work towards more simplified methods to monitor and manage anthelmintic efficacy on sheep farms, including some work on cattle also. It was led from Queen's, but a very large part of it was conducted at Morgan, led by Fiona Kenyon, and Leslie was involved as well to make sure that the outcomes are translated to SCOPs. The objectives of the project as a whole were quite ambitious. There was to survey sheep and cattle farmers and what they do at the moment. There have been other surveys, as Dave pointed out, but it's important to keep updating this and using different populations to provide more information on current practices. We wanted to also update what we know about the status of resistance across sheep farms in the UK, and to improve knowledge, really to have some back of house work in the lab while we were gathering those data to try to probe a little bit how we can adapt standard fecal egg count tests to become more usable, if you like, by farmers and their advisors. We wanted to extend that work also to the testing for species composition. There are good molecular methods already in place, but it's very difficult to apply them unless you've got a research lab on board, and we really need tests that are more applicable and more usable in practice. There was some epidemiology. I'm not going to really talk about those epidemiological models around refugia. That could be a whole talk in itself. I'm happy to discuss it in the Q&A. And also the translational and knowledge exchange component is very important, but that segues nicely onto Leslie's presentation next. So the farmer survey, rather than trying to get broad coverage of a superficial survey, we tried to get detailed information from a smaller number of farms to really try to understand what they're doing and why. And one of the headline findings from that is that most of the sheep farmers are starting to feel they have problems with anthelmintics on their farms. As compared to the blissful ignorance or complacency among cattle farmers, it does seem that the message, or at least the awareness of drug failure on sheep farms is getting quite widespread now. To which drugs did farmers feel they had poor performance? Well, it was those that were most widely used, so benzimidazole and macrocyclic lactones. Those were the drugs that were flagged as problematic. However, even though half of the sheep farmers felt that the drugs weren't working very well, it was a tiny minority who actually went forward with some diagnostic investigation there. So it was less than a third of farmers went on to diagnose resistance with their vet, even using pooled samples. And worryingly, quite a large number of farmers were, or the most common reason for suspecting drug failure was that the drug was not having the effect that they would expect on the animal performance. And in cattle, at least, this was requiring more treatments that would normally be applied. And these are the proportion of farmers who reported drug failure. So if the perception is that you've got perceived drug failure on about half sheep farms, how does that compare with the real situation when you go out and measure anthelmintic effectiveness? Well, it's an underestimate. So this is the part of the study that's conducted from Morgan. And you can see here that the vast majority of sheep farms were not giving effectiveness of benzimidazole and macrocyclic lactone treatments in particular that would be expected. That's a progression from the last 5 to 10 years. It seems to be that the majority of farms now are not getting what they need out of those drug classes. And what's also evolving is the level of reduction is reducing. So you can see here that among the macrocyclic lactones, for example, only reducing egg counts by about half and the benzimidazoles by a third. So the level of failure is also advancing, and this is getting to the levels where we would expect decreased performance and a failure of control. So failure of the drug is not the same as failure of control. The drug will start to fail and detect anthelmintic resistance if it's not clearing 95% of the worms, whereas if you start to get the situation where the drug is only clearing half the worms, you might expect a failure of control. And that's when the problem becomes serious. So we seem to be missing an opportunity to pick this up at an earlier stage. So the proportion showing acceptable fecal egg count reduction was lower than expected by farmers. If you look at the proportion of farmers reporting suboptimal performance of these drugs, and also the percentage reduction in fecal egg count was much lower than we'd want to see. There was variation by species, and we've had a little bit of information on that already this morning, but when using NemaBiome and Diagnostics molecular methods, you can see here that the species composition varies quite a lot, and the species surviving treatment by different drug groups also varies a lot. So the orange color on the left of each of these panels is Teledorsagia circumcincta, one of the more pathogenic, one of the more common species. And you see that the reduction in egg count attributable to Teledorsagia is much, much lower. So there's much more resistance in Teledorsagia than the other species. But if you look at these panels in turn, you can see the benzimidazole on the left, a lower overall efficacy, much more resistance in Teledorsagia, but a wide range of species being affected and not being cleared. Whereas if you look at the right panel, the monopantel graph, you will see that it's much more effective, that perhaps some species of Trichostrongylus and Teledorsagia and Chabertia are leading the way in terms of some failure to clear those, but there are still some species there that are completely cleared by monopantel. And macrocyclic lactones and levamisole intermediate. But you can see the macrocyclic lactones, ivermectin and related drugs failing quite commonly for Teledorsagia, but still working quite well against other species, mostly working well against Haemonchus, but not all the time. These are aggregate data, and what you find on an individual farm could be quite different, but these are the trends that we're seeing. However, these trends seem to be quite different. So if we took a different population that we looked at from Belfast, but further south in the UK, actually, we find a very different picture. So here you can see a group of farms where actually Haemonchus contortus was the most common parasite pre-treatment, and that proportion increased after benzimidazole treatment. So benzimidazole resistance in Haemonchus, quite common in this group of farms. And yet after levamisole, didn't find Haemonchus at all. So in this small group of farms, levamisole would clear Haemonchus, but benzimidazole won't. Why does this species composition matter? Well, it varies quite widely, not only geographically, but also seasonally. Haemonchus is quite an ephemeral parasite. It can quickly dominate and then disappear depending on climate and other conditions. So if you repeated these fecal egg count reduction tests later in the season, you could get completely different results, a different group of animals in a different year. And this could undermine the conviction with which you're able to persuade farmers to implement different control procedures, because they're saying the test is unreliable, it's different every time I do it. Well, there are very sound underlying biological reasons for that variation, and one of that is variation in the species composition. So it's important to realize that where you have that fluctuation, the fecal egg count reduction test results will change. That's not a failure of the test, that is underlying biological variation. Another implication is options for coping with resistance. It's going to depend on the species profile, but also what's happening on an individual farm. So in this farm, for example, if you had a Haemonchus problem and you knew that it was resistant to benzimidazoles, but levamisole could still clear Haemonchus on that farm, then that is an option for you to go ahead and control Haemonchus. And by no means saying that's a general trend. There's plenty of examples of levamisole resistant Haemonchus also, but just having that knowledge really empowers the advisor and then the farmer to do something very targeted about it and get the most out of remaining drugs. So far, this is not the end. I'm just taking a breath here, but the results of that first part really confirmed what we already suspected, in that farmers are starting, I would say, to switch on to resistance, at least in sheep. But the situation is worse than they think. The species profile affects outcomes of testing, it affects management options, but there's very little monitoring or diagnosis of resistance. So if we come out with a message now that you should be doing a lot more fecal egg count reduction tests. You should be really drilling into the species profile. It's not very helpful because even a full fecal egg count reduction test involving the vet or other advisor is going to be quite a lot of investment in time and expense. And if we now say you now have to find a research lab to provide the species information, that's not going to give you any uptake. So what we need actually is tools for efficacy monitoring that are simpler and more precise. And there's obviously a tension or trade-off there. How do we make things both simpler and more precise? Well, in terms of simpler, there's been quite a lot of work done before and during this project on pooled fecal egg count reduction tests. So if you take a bunch of individual fecal samples and conduct fecal egg counts on those separately, you get most precise outcome, and you get information on the variability and the confidence in your estimated fecal egg count reduction. If you take those individual samples and pool them and mix them up, you just get a single fecal egg count pre-treatment and a single fecal egg count post-treatment, and that will give you a single number for the estimated reduction. You lose out on the confidence in that estimate because you don't have information on the variation, but you gain hugely in the amount of work that you need to conduct that. So we believe there is an argument for using regular pooled fecal egg count reduction tests or tests of wormer effectiveness really as a routine diagnostic, a routine source of information whenever sheep are treated. And if that is done regularly enough, it can be done cheaply, it can be done in a routine manner, and problems will become apparent sooner. The caution around that is the accuracy of the pooled fecal egg count reduction test, and the work back of house, if you like, in Morgan showed here a series of farms where both the pooled fecal egg count and or composite fecal egg count equivalently, or the individual fecal egg count reduction tests we use on the same samples. And you can see that there is some variation. Farm 5, for example, there's some variation in the percentage reduction there. But what's important is that in none of these cases did you get classification error, misclassification. So in none of these cases did the pooled fecal egg count reduction test give you substantially different answer on how well the drugs are working. It's important to note that those tests were done on the same samples, and there is much more variability if you have variation in the way in which those samples are collected and processed. And we have quite a lot of grasp now of what really matters in terms of accuracy of pooled fecal egg count, and therefore their use as a reduction test. What really matters firstly is the number of animals. Parasites are aggregated or over-dispersed. We talk about the 80-20 rule, where 80% of the parasites are found in 20% of the animals. I suppose in many organizations, it's not just restricted to parasites. You might say that in many organizations, 80% of the work is done by 20% of the people. It's not evenly distributed, and parasites are not evenly distributed either. So it's really important to sample a sufficient number of individuals. There's no magic threshold for that. We do talk about 10 or 15 is what you're aiming for. Otherwise, you're getting too small a number, and the result of your test will depend entirely on which individuals you happened to sample. The second thing that matters a great deal is how well you mix those individual fecal samples. You have to mix them really, really well. If you just take a load of fecal pellets and you stir them up, then you subsample that, you're only getting samples from effectively a few individuals. You have to mix those really well. Things that matter a little less are how precisely you measure the weight of those individual samples, how you collect those samples. You can collect them off the pasture, provided they're reasonably fresh, and get accurate results. So what we found was really in support of using pooled fecal egg count reduction tests as a monitoring tool. How do we make these tests more precise? Well, that is really about species quantification, and it's not enough to just identify the presence or absence of particular species in a sample. It's really about the relative proportions, because we need to know in which species we are starting to see resistance. So we have methods for this already. We have the Oz diagnostics method, which is commercially available, and we have the NemaBio method, which is widely used in research, and you've seen some results from that earlier. And what we see here is comparing those methods. There are some differences, for example, here in the proportion of teal dosagia found in different farms, but they're not that large. So you can certainly see the majority of the farms are teal dosagia dominated. You see that through these different methods equally. And you also see farms where teal dosagia is absolutely not dominant, and you have a really wide mix, including Trichus strongylus coming through. And part of that is seasonal, geographic, age-related. However, I wonder if we could go further, because we still need quite expensive equipment. We still need quite a lot of expertise. We still need access to a suitable lab to apply these tests. So what we are interested in doing is taking that closer to the field. So we adapted a conventional PCR, which can now be done on portable kits. It's very small investment. It could be set up in any working lab, really, and try to get some quantitative information out of those. What we found was that there was more variation than using nemabiome, the cutting edge, sort of as close as we've got to gold standard, really. It was more variable, but there was very, very strong correlation. So these new methods are not going to be able to say you have 79% or 36% hemoncus, for example, in your sample, but it will tell you, look, most of those parasites surviving treatment were teal dosagia, or an important number of survivors of treatment was hemoncus. What's important about these tests are firstly that they can be done fairly cheaply with limited training and limited post-result interpretation, but also they're pretty cheap. So this is just the reagent costs, but those reagent costs are getting to the level now where I think it makes sense actually for farmers and advisors to be using that, if we can deliver it into labs that are closer to the farm than we are. Finally, communicating complex results, then how do we take this additional information, the variable confidence in a fecal egg count reduction depending on how it's being conducted, the species level information, and communicate it effectively to advisors, to farmers, to labs, and how do we translate those into pathway tools? There was quite a lot of work done in this project on that, but it led directly into what Leslie is going to speak about in the next presentation, so I won't go further on that. We did, however, in our survey start to look at communication and knowledge and attitudes in a little more depth, and just to give you a couple of bottom lines from that, we did try to separate out the knowledge and attitudes around anthelmintic resistance. So this would be, for example, the level of concern that the farmer had around this issue in industry in general, their own farm, whether they've talked about it. We try to map good farming practices. So this would be, for example, a number of treatments, quarantine treatments, whether doses applied to weight, whether TST and TT are being used. And then we looked at their experience of anthelmintic resistance. So this is suspected and confirmed resistance. And what we found in sheep was that there was a strong correspondence between knowledge and attitudes of anthelmintic resistance and what farmers are doing in terms of good farming practices. And there was also a link between good farming practices and them having experienced anthelmintic resistance. Now, I very much hope that that's in the direction of having experienced drug failure leading to a change in practice, rather than good practices leading to experience of anthelmintic resistance. The statistics can't tell us the direction of that effect. What we didn't find was that the knowledge and attitudes of anthelmintic resistance were tallied to experience of anthelmintic resistance. So there are farms here, there are farmers who are aware of the issues, who have applied good farming practices, but have not yet at least experienced anthelmintic resistance. And that's a very positive outcome. It does mean there are people who are doing the right things or the recommended things, but not because they've been forced to do so, because they're aware this will help them in the future. I've frozen a bit. Could someone tell me if they're still hearing me?
Yes, can still hear you. Great,
thank you. That is coming up now. So not part of this project, but relevant to it. Every time we do a survey like this, and whether it's a questionnaire survey or whether it's a sampling survey, we encounter bias, of course. Those farmers who elect to take part are perhaps not fully representative of the general population. And if we do another survey 5 years later on a different population, we can't tell for sure whether we are seeing a change, or whether it's just a different population. So what we started some years ago with Gerald Coles was to go to the Sheep Southwest show, a small and smaller and more geographically restricted population of farmers, and every couple of years going and asking them fairly superficial questions, but just to see if we can pick up some trends. And what we find overall was that, at least when we started, 80% of farmers believed that anthelmintics were working on their farm. This is sheep farmers. Minority have tested for anthelmintic resistance. A majority at the beginning were applying dose and move, which is a strong selector for anthelmintic resistance, and very few using any kind of selective treatment. We do see changes over time. So when we amalgamate these kinds of behaviors into a good practice score, that has been going up. I'm quite anxious to analyze this year's results and see if that's being maintained, but certainly we saw an increase in good practice uptake, and that was strongly related to having heard of SCOPS. So the message from SCOPS is definitely getting out there. The use of fecal egg counts to plant treatments was rising, and the majority of farmers claim to be taking specific steps to reduce resistance, and this is towards the end of that period. That's in 2019, that's just pre-COVID. And that's just as well, because when we asked farmers what they would do if anthelmintics failed completely on their farm, there wasn't a lot of planning around that, and the majority of farmers basically said they'd have to stop. So the risk of anthelmintic resistance, if it reaches multiple drugs with no other recourse to parasite control, making sheep farming impossible, was really widely recognized. So we're not taking questions in these presentations, but I just want to park this conclusions discussion slide really for the Q&A. We have developed new tools as part of this VMD-funded project that will enable more information to come through and increase awareness among farmers. And as awareness increases, perhaps the scope to take up those new tools will improve, because there'll be more demand for fecal egg counts, there'll be more demand for species characterization, and that is what is needed in order to drive the accessibility of those new tools. But of course, we only want that cycle because we want action, and I think that's perhaps the more challenging part rather than the science.